we go. So today, 8:31, we're going to talk about graphing linear equations. And again, if you are a learner that likes to listen, you can just listen, and when I'm done, if you want to take a picture of my notes, you're welcome to. Some kids learn better that way. It doesn't matter to me. Whatever way you learn best, that'll work. Okay, so I'm going to underline graphing of linear equations. I like to highlight my notes because for me, if I highlight it, it pops. So the word linear, before we even start, this word linear will always in math mean straight. There's lots of lines. I mean, there's curvy lines, wavy lines, whatever, but if it says linear, it's always a straight line. Every line has got a slope and a y-intercept. So I'm just going to draw a picture of a line. Okay. This would be my x-axis and my y-axis. Now, x and y are pretty sterile. It's just a general form. We use x and y just in order that we can learn concepts, but it could be, in a real-life situation, it could be distance and time. Oops, I want to put distance here. Distance and time. So we'd have T and D, okay? We use X and Y as a general term because that way we just practice the, how does it work? But most problems are more like distance, time, whatever. So it's an application. Well, let me draw a line and then we're going to talk about its equation. Okay, so if I just come on out here and we just start here. Here's my line. And every line has a name. Every different line has a name. The name of this line, well, we're going to use y equals mx plus b. And I'll slow down for a second, okay? Every line has a name. And its name comes from y equals mx plus b. The b is the y-intercept, where it crosses. The b is the y-intercept. In this case, right there. That's my y-intercept, where it crosses the y-axis. Intercepts, okay? How am I doing? Am I going too fast? Please let me know if I get going too fast. M is the symbol for slope. I don't know why it's M. It just is. But M is the symbol for slope. And slope has to do with like walking down the stairs. You notice like graph paper is made out of grids, right? Graph paper is made out of grids, so you got to go and follow the grid. Slope is defined as the rise over the run, which is different than points, because points are over then up. Slope is rise over run, which is different than points, right? Points you graph by going over up. Slope, it's rise over run, okay? Now, this line here has a name, doesn't it? You guys, what is the name? Anyone want to tell me what the name of this line is? It's going to be y equals, hold on, brand new pin. Y equals, let's see, it goes down 1 over 2, 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 x. Okay, there's my slope. Plus 4. That is the equation of this line. a real life or a better example would be one like this. Okay. Here's a better example of something that's a real life situation. Better make sure these are miles. And these are in terms of hours. Okay. Well, if I look at my graph in words, what's going on? If I look at my graph in words, that actually is telling me something. That graph is telling me something. So it started at 10 miles. So maybe I'm 10 miles from home, right? Does that make sense? And I'm going 10 miles per hour because my slope, so I'm 10 miles from home. That's my starting point, my y-intercept, and my slope is up 10 over 1. My scales are different, but it's up 10 over 1, or I'm moving at 10 miles per hour. So my equation is going to be, ready? D equals 10t plus 10. How's that for an equation? Right? So there's a line. It's a straight line, but it has an application. Now, one of the things I made sure I didn't do on this is I didn't put arrows on my green line. I did not put arrows on my green line. Yeah, I can't drive forever. I mean, really. I mean, it sounds like fun, but really can't. In fact, how long did I drive? 4 hours. And that's my domain. Remember that at all? My domain is 0 to 4 hours. And then how far did I drive?
50 miles. 50
I drove 40 miles, so from 10 to 50. And that would be my range. Remember that? And we'll talk about that more, domain and range. Okay? All right, how's everybody doing? Okay, so let's graph some lines. Okay, first line, example 3. Let's have you graph this line. Y equals 2/3 x minus 4. Okay, let's have you guys graph this. So I know for sure I'm going to have to draw my x and my y axis, right? Hopefully this is a review. Thumbs up if this looks like a review. Okay, good. If this is the first time you've ever seen this, I'm sorry. I really am. Because I'm assuming you know how to do this. Okay. X and y axis. My y-intercept is at -4. Boom, right there. Slope of 2/3 up 2 over 3, up 2 over 3, up 2 over 3. Draw it in. Okay. How am I doing? I'll wait for you. Julian's bored again. I know. You get bored. You should be teaching. Should make you teach, huh? Should make you teach, huh? Okay. Thumbs up. Am I going too fast? Okay. Connie, I can wait a little bit. I got to babysit anyway, don't I? Yeah. Connie, give me thumbs up when you're ready.
How do you know where on the X and Y line to start?
Great question. This number is your starting line, okay? Here's an analogy I like to give kids if this is a little confusing. Okay? Starting line. Think about racing. Okay? Okay, ready? Whether it's race cars, motocross, or whatever, but here's your starting line. This is my starting line. Does that make sense? Here we go. So we are starting here. Somebody else might be starting somewhere else. We're starting here, and then we're driving. Which way we're driving? Up 2 or 3, up 2 or 3. Okay. Does that help?
Yeah, I just forgot which number that.
Yeah, it's been a year, right, you guys? For some of you a year, some of you it's been, summer. Okay, let's do a second example, okay? Example number 4. Let's graph y equals 2x.
Just 2x.
Yeah, just 2x. So there's some missing numbers, aren't there?
Yeah.
But they're not really missing, they're just invisible. They're not missing, they're just invisible. So what number is invisible?
0.
Yeah. Plus 0, because we're going to start at 0. And Dulce said we're also invisible number 1. Right? Because the number 2, as a fraction, has to be a fraction. We need a fraction here because slope is a fraction, right? Slope is a fraction. You have to fraction here. Dulce knows that the number 2 is 2 over 1. And so the invisible numbers I just drew back again. So we would start at, where am I going to start? Or the origin. Fancy word, but that's called the origin. And then my slope is up 2 over 1, up 2 over 1, up 2 over 1. Good. Okay. And I'm going to graph that in. Couple more, and I'll be done, okay? Okay. Turn the page when you're ready.
Wait, we have to turn the page?
Well, I have to turn the page. You may not have to. I have to turn the page. Okay, all right, example, I'm going to put 2 examples down side by side, okay? Example, what number I'm on now? 5. And example 6. I'm going to put them down side by side, okay? One is y equals x plus 3, and the other is y equals 3. So I want to look at both of these, okay? Example 5 has some invisible numbers. What are they? Okay. Actually, 1. That's a 1x. Everybody agree? You guys agree that's a 1x? And 1 over 1 still gives me a fraction, doesn't it? So that's easy. What's my starting line or my y-intercept? 1, 2, 3 on the y-axis, and then my slope of up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Connect the dots. So positive slopes always go uphill from left to right. That makes sense, doesn't it? Right? We read from left to right, so we're going uphill. Negative slopes go downhill. Negative slopes go downhill. Now what about example 6? Okay, y-intercept at 3. I totally agree with that. So I agree, totally agree. Y-intercept at 3. Totally agree. What's my slope?
0.
It is invisible plus 0x. Right? I wouldn't write 0.
Is 0 divided by 0?
It's
Zero
it's
over
undefined. Stop. 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 It's undefined. We're not doing that. Sorry, Julian. So it's 0 over 1. So watch. Up 0 over 1. up 0 over 1, up 0 over 1, up 0 over 1. So if it's just y equals some number, it is going to be a vertical line. Sorry, horizontal line. I said that wrong. Y equals any number, just the number, it's going to be a horizontal line, okay? And here is why it works. And I'll let you get caught up. A lot of kids do this backwards. They'll see y equals 3, they'll see the y axis, and they'll do it like this. No, y equals 3 is not this. No, that'd be x equals 3. Yeah, right? So think about this. What's the y value?
3.
What's the y value? What's the y value? What's the y value? Isn't the y always equal to? Isn't that an easy way to remember it? And then if it's x equals, what's x equal equation?
3.
If I had x equals, yes, any x equation is a vertical line, but we're not going to talk about those because
We're not there yet.
we're not there. Those are what we call death. We don't want to do those. Those are non-functions. We haven't talked about what functions are, but those are non-functions, right? Okay, last but not least, last example I want you to do is this one. Example 7. I have a 2x minus the 3y equals 12, okay? There's two ways to tackle this. Two ways to do it. One way is to solve for y. So it says y equals, okay? That is one way to do it, okay? So, two ways to do it. One way is to solve for y, because all of these, we want to put it in the form of y equals mx with b. So I want it in the form of, I want y equals mx plus b, okay? So what I'm going to have to do is solve for y. All right. Well, here's y. Here's y. There's y. Get rid of everything around it. So if I get rid of everything around the y, then I've solved for y. Does that make sense? I have to get rid of the 2x, get rid of it. I have to get rid of the negative 3. Okay? Here's the y. Get rid of everything around it. Solve for y. Okay? So first I'll get rid of the 2x. I'll go minus 2x to both sides, right? Okay. The 2x is gone. I'll have a negative 3y equals 12 minus 2x is not 10x. 12 minus 2x is not 10x. 12 minus 2x is just 12 minus 2x, okay? That's an x. That's an integer. And then negative 3y is like negative 3 times y. It's not subtract, it's multiply. So now I'm going to divide by negative 3, divide by negative 3, divide by negative 3, and I get y equals a negative 4 plus 2/3 x. I can graph it now, can't I? Start at negative 4. I'll go up 2 over 3, up 2 over 3. And there it is. I'll let you get caught up. Because before I'm done, there's another way to do this problem. There it is. Remember it? You remember the cover-up method? The cover-up method. So there's another way to do this that's easier. I'll let you get caught up. Okay, if it's in standard form, and I'll talk more about that. It's in standard form. That's in standard form. It's not intercept form. It's in standard form. Cover-up. Okay, x is gone. X is gone. Solve for y. What would you do? Solve for y. Right here. Solve for y. Divide by negative 3. Okay. Divide by negative 3. What do you get? Y equals negative 4. Cover up. 2x equals 12. What do you get? X equals 6.
Oh,
Slick, huh? Connect dots. Isn't that cool? Isn't that nifty? Much easier, huh? Okay, so that's all I have. I do have homework for you. You're going to have to put your homework on a piece of graph paper. If you need graph paper, I have it.